At 6:42 a.m. on October 15, 2024, Robert Jensen stood beside a Grimm GT 170 potato digger in a field near Idaho Falls, watching the temperature display on his phone drop to 31 degrees Fahrenheit, while 180 acres of russet Burbank potatoes waited to be harvested. 52 years old, third-generation potato farmer, 1,200 acres under management. The soil temperature sensor read 38 degrees, barely above the 36-degree threshold where tuber bruising increased exponentially during mechanical harvest. His processing contract with McCain Foods required delivery of 4.8 million pounds within 24 hours of digging, with quality specs allowing maximum 3% bruise damage. Weather forecasts showed hard freeze tonight, dropping to 24 degrees, which would convert starch to sugar in unharvested potatoes and make them unsuitable for French fry processing. Standard practice said wait until 9 a.m., when air temperature climbed above 40 degrees and bruise risk declined. His McCain contract included a $42,000 penalty for late delivery and immediate termination for out-of-spec quality. Jensen had 180 acres to dig, 14 hours until the processing plant cut off, and a choice between certain bruising from cold harvest or certain crop loss from freeze damage. He signaled his crew. They'd start digging immediately. Idaho's potato harvest operates as a precision-timed supply chain, moving 13 billion pounds annually from field to frozen food in 48 hours. 300,000 acres. That's 468 square miles of cropland, larger than Los Angeles, dedicated almost entirely to potato production that supplies 30% of America's potato consumption. Every September through November, approximately 6 million tons of potatoes must be mechanically harvested, transported to temperature-controlled storage facilities maintaining 45 to 50 degrees Fahrenheit, or moved directly to 30-plus processing plants converting raw tubers into French fries, hash browns, and dehydrated products within 24 hours of harvest. The operation requires specialized equipment, potato diggers costing $450,000 that lift tubers from soil without bruising, bulk handling systems moving tons per hour, and integrated logistics where harvest scheduling syncs with processing plant capacity and storage availability. This is agriculture as just-in-time manufacturing. Zero inventory tolerance. Quality specifications measured in percentages of acceptable defects, and timing windows measured in hours where delays mean crop loss or contract termination. Robert Jensen learned potato farming from his father, who learned from his grandfather, who planted Idaho's volcanic soil in 1962 when the state was transitioning from wheat and sugar beets to potatoes. His grandfather had grown 40 acres using equipment borrowed from neighbors, storing potatoes in unheated barns, selling to whoever offered cash. His father expanded to 320 acres in 1985. He built the first temperature-controlled storage and signed contracts with processing plants that demanded consistent quality and reliable delivery. Jensen took over in 1998, expanded to 1,200 acres by 2015, and invested $2.8 million in modern harvest and storage infrastructure required to meet processor specifications that had become impossibly precise. The evolution represented industrial agriculture's complete transformation, from growing food to manufacturing components for a supply chain that demanded perfection. The Grimm GT 170 potato digger Jensen operated cost $420,000 new in 2021. The 4-row machine weighed 28,000 pounds, could harvest 8 acres per hour in optimal conditions, and used a web system to lift potatoes from soil while shaking off dirt and debris. Optical sensors detected and removed rocks, clods, and damaged tubers before potatoes moved onto trucks for transport. Every function was engineered to minimize bruising, the industry's constant enemy. Bruised potatoes developed black spots internally that showed as dark specks in French fries, causing rejection by quality control and termination of supply contracts. The digger's settings: web speed, separation gaps, drop heights, required constant adjustment based on soil moisture, tuber size, and temperature. Being too aggressive and bruising increased. Too gentle and harvest speed dropped, creating bottlenecks that rippled through the entire supply chain. The economics of Idaho potato farming created dependencies impossible to escape. At processor contract rates averaging 9 cents per pound for russet Burbanks meeting quality specs, each acre yielding 45,000 pounds generated $4,050 in gross revenue. Seed costs ran $850 per acre for certified disease-free tubers. Their fertilizer added $620 per acre. Potatoes were nutrient-intensive crops requiring precise nitrogen, phosphorus, and potassium management. Irrigation costs in Idaho's desert climate: $380 per acre for pivot systems and well operation. Chemicals for disease and pest control: $290 per acre. Harvest costs, including equipment, labor, and transport: $680 per acre. Storage costs, if not direct delivered: $180 per acre for temperature and humidity control. Total operating costs: $3,000 per acre against $4,050 revenue. That left $1,050 profit per acre before equipment depreciation and land costs. Across 1,200 acres, Jensen's operation generated $4.86 million in gross revenue and maybe $1.26 million in operating profit. After fixed costs and depreciation, actual net income around $340,000 for managing a $6.2 million operation. The return on assets was 5.5%, barely above what Treasury bonds paid with zero risk. At 7:15 a.m., the digger engaged. Rotating webs lifted potatoes from soil 8 inches deep, shook away dirt, and deposited tubers onto a conveyor feeding into bulk trucks positioned alongside. Each truck held 50,000 pounds, approximately 1 acre's harvest. When full, trucks drove 14 miles to McCain's Idaho Falls processing plant, where potatoes moved immediately into the production line. The coordination was extraordinary. Harvest rate had to match truck availability, which had to match processing plant capacity. Over any bottleneck, digger breakdown, truck delay, plant slowdown, created cascade effects that turned fresh potatoes into spoiling inventory. Jensen's phone buzzed at 8:40 a.m. Text from McCain's receiving manager: Line 3 down for maintenance. Reduce delivery rate to 100 to 20,000 pounds per hour until 2 p.m. Jensen calculated instantly. Normal rate: 180,000 pounds per hour across his 3-truck rotation. Reduced rate: 120,000 pounds per hour. That's a 33% slowdown. His remaining 180 acres would take 27 hours to harvest and deliver at reduced rate instead of the planned 18 hours. He couldn't finish before the midnight cutoff. The freeze would hit unharvested acres. He'd lose approximately 60 acres worth $243,000 in crop value, unless he found alternative processing capacity. He called Lamb Weston's processing plant 40 miles south. Got capacity today for 2.4 million pounds? What quality? Russet Burbank. 3.5-inch minimum, less than 2% defects. Fresh dug, Lamb Weston, we can take it. But our rate is 7.5 cents per pound, not 9 cents. The math was brutal. 2.4 million pounds at 7.5 cents instead of 9 cents meant $36,000 in lost revenue. But $36,000 loss was better than $243,000 crop loss from freeze damage. Jensen accepted, split his harvest between McCain and Lamb Weston. The flexibility saved the crop but destroyed the profit margin. Every unexpected problem, equipment failures, plant shutdowns, weather threats, got resolved by farmers absorbing costs that processors wouldn't. By noon, Jensen had harvested 78 acres and delivered 3.51 million pounds. The temperature had climbed to 44 degrees. Bruise risk had dropped. The digger ran smoothly. His crew, 8 workers including truck drivers, equipment operators, and his daughter Anna managing logistics, coordinated efficiently. Anna had returned from Boise State 2 years ago with an agricultural business degree, bringing data analytics and supply chain optimization knowledge her father's generation never learned. She tracked every metric: harvest rate per hour, defect percentages by field section, fuel consumption, labor productivity. The farm operated like a factory now. Efficiency was everything. McCain called at 2:30 p.m. Line 3 back online. Resume full delivery rate. Jensen rerouted trucks back to McCain. The Lamb Weston diversion had cost him 2 hours of transit time, but the crop was saved. By 6:20 p.m., he'd harvested 140 acres. 40 acres remained. The sun set at 6:48 p.m. He activated the digger's LED lights and kept working. Night harvest was standard during peak season, when processing plants ran 24/7 and delivery windows were unforgiving. At 9:35 p.m., Anna called from the farm office. "Dad, we've got a problem. Storage facility called. Their cooling system failed. Temperature's climbing. They need to empty 600,000 pounds tonight before it spoils." Jensen stopped the digger. These 600,000 pounds represented 13 acres of potatoes harvested earlier and stored pending processing capacity. Those potatoes had to move to a processor within hours, or they'd warm above 50 degrees and begin sprouting, rendering them worthless. But moving stored potatoes meant diverting trucks from current harvest, which was already racing the freeze deadline. "Can we get them to another storage facility?" "All nearby facilities are at capacity. It's processed tonight or lose the crop." Jensen made a decision. Finish the remaining 40 acres first, the fresh crop in immediate freeze danger. Then mobilize all trucks to move the stored potatoes. He'd work until 4 a.m. if necessary. Sleep was optional during harvest season. Crop loss was catastrophic. The final 40 acres came off the ground at 11:42 p.m. Jensen shut down the digger, climbed out into air that had dropped to 28 degrees. His remaining potatoes were safe. Now came the second crisis. He drove to the storage facility, where his crew was already loading trucks with potatoes from the failed cooling system. The operation ran until 3:20 a.m. All 600,000 pounds delivered to McCain's night shift. 0 crop loss. Jensen's crew earned massive overtime. His fuel costs doubled. His body ached from 21 straight hours of operation. But the crop was saved. Anna compiled the final harvest numbers on October 16th. Total harvest: 1,200 acres producing 54 million pounds of potatoes. Your gross revenue at blended processor rates: $4.68 million. Operating costs, including emergency overtime and Lamb Weston's lower rate: $3.84 million. Net profit before fixed costs: $840,000. After depreciation and loan payments, actual profit of $180,000. Down from the projected $340,000 due to the processing plant slowdown, the Lamb Weston diversion, the storage facility failure, and the resulting overtime and fuel costs. The operation had executed flawlessly from an agricultural perspective. Every acre harvested, every quality spec met, every deadline achieved. But the margin had collapsed from 28% to 15% because of supply chain disruptions Jensen couldn't control. He met with Anna on October 20th to discuss next season. She showed him data. Processing contracts were offering 8.5 cents per pound for 2025 harvest, down from this year's 9 cents. Input costs were projected to rise 6% across seed, fertilizer, and fuel. The profit per acre would drop from $1,050 to approximately $720. At 1,200 acres, the operation would generate maybe $864,000 in operating profit, or $120,000 after fixed costs. The return on investment would fall to 1.9%. Dad, we can't survive at these margins. We need either more acres to spread fixed costs, or we need to vertically integrate. Buy into processing capacity so we're not completely dependent on processor contracts. More acres means more debt. We were already leveraged at $2.1 million. Vertical integration means $5 to $8 million to build even a small processing line. The bank won't finance that. Then, what's the option? Jensen didn't have an answer. The squeeze was systematic, not exceptional. Processors had consolidated. 5 companies now controlled 70% of Idaho's potato processing capacity. They dictated contract terms. Farmers competed for contracts by accepting lower rates. Input suppliers had also consolidated. 2 companies sold 60% of certified seed potatoes, setting prices farmers couldn't negotiate. Equipment costs had tripled over 20 years, while crop prices had increased maybe 35%. The economics were collapsing for mid-sized operations like Jensen's. Too large to quit easily. Too small to compete with corporate farms running 10,000-plus acres. Robert Jensen continued potato farming through 2026, watching margins compress further as processor contract rates dropped to 8 cents per pound, while operating costs climbed 8%. In spring 2027, his bank reviewed the operation's financial trajectory and declined to renew his operating line of credit unless he provided additional collateral he didn't have. Jensen called Anna. We're out of options. The numbers don't work anymore. Sell to one of the corporate operations? They're offering $8,200 per acre for land and $1.4 million for equipment. Or after paying off debt, we'd net maybe $2.8 million. Anna ran scenarios. The family could retire on $2.8 million. Or they could take that capital, move to a cheaper agricultural region, start smaller. But starting over at 54 felt impossible. Jensen accepted the corporate offer in June 2027. The acquiring company integrated his 1,200 acres into a 14,000-acre portfolio managed centrally with hired agronomists, automated systems, and economies of scale that made 8 cent per pound contracts viable through sheer volume. Anna took a supply chain management position with McCain Foods, ironically working for the processor that had been her family's biggest customer. She helped optimize their agricultural sourcing, using data analytics to improve harvest coordination and reduce waste. The system became more efficient. Family farms became less viable. The potatoes kept moving from field to frozen food in 48 hours. The supply chain kept functioning. Individual farmers disappeared into corporate structures that treated agriculture as manufacturing inputs rather than family legacy. Idaho's 300,000 acres continue producing 13 billion pounds of potatoes annually, supplying 30% of U.S. consumption, generating $4.2 billion in revenue, feeding processing plants that operate 24/7 turning tubers into frozen foods consumed globally. The harvest happens every fall regardless of who owns the land. The 24-hour field-to-processing timeline persists regardless of who operates the diggers. The system works through precision that family operations pioneered but can no longer sustain profitably. The potatoes keep flowing. The families keep exiting. Industrial agriculture optimizes efficiency. Individual farmers become obsolete. If this story moved you, please like and subscribe. Your support helps us preserve these histories of American agriculture's transformation. Tell us in the comments where you're watching from and whether you understand the supply chain pressures crushing family potato farms. Thank you for keeping their stories alive.